Okay, so in this video we're going to go over quiz 4 from the ENGI 1331 summer 2018 semester. This quiz is on debugging, and in addition to just going through the answers of the quiz and how you get the answers, I'm also going to go through some debugging strategies that you might want to take when you are might want to use when you're taking a quiz or an exam that has a debugging problem on it. So first thing we do is we read through everything at the top. So this just says look through the mistakes. There are a total of 8 lines of code. 8 lines of code that corresponds to the 8 boxes we have. That means that there are 8 errors that we need to find. I'll note that sometimes there is more than one way to solve a certain problem with the code, and I'll go over that more in depth later. But if you find a way to solve the code that is not necessarily the exact written way that I do it or that is on a solution key, that does not mean it's wrong. When we grade these, we check to see if the solution that you came up with is accurate. So, reading through, first you see some comments. In debugging problems, you always want to read the comments at the beginning of the code because they tell you what the code is saying. They tell you what the code needs to do, and if you know what the code needs to do, you can figure out how you should figure out what errors you should necessarily check for. If you don't know what the code needs to do, you cannot check for things called computational errors. So a computational error is different from a syntax error, which most of these are. A computational error is something that will run fine in MATLAB, but will not give you the correct calculations that you need. So for example, if I was trying to make a variable that's 5 times a previous variable, but instead I divided the previous variable by 5, I wouldn't get an error. I would just get I would just not get the correct value. And so that's a good example of a computational error. So going through, we have our housekeeping commands, COC and clear. We do not need the close housekeeping command, and that is not an error. We do not have the close housekeeping command here because nothing in our code is working with graphs or tables or figures, so there's nothing for us that could open that we need to close later. So even if we run this code several times, there's no need for the close statement. That is not an error. Our first error is in line 7, so we have wave in all caps equals input. What is the measured wavelength in nanometers? We have our apostrophes on nanometers. These apostrophes could also be quotation marks. That would work fine as well. That would not be any kind of error. Either of those work. And then we see a S here. Now the S is kind of strange because within S we're expecting a string, some kind of text, right? But with this input statement, the measured wavelength, we're looking for a number. We're looking for something in nanometers. And if we go back to our comments, we're calculating things with nanometers. So there is no reason here to have an S right here on the input statement. So our first error is in line 7, and the correct line of code here would just be wave equals input semicolon. To denote a sentence, you can just use a ... You don't have to write out the whole sentence, which can be very useful. You can also, if you want, in parentheses, put no S, just to clarify that you are removing that S from your line of code. Moving down, I see an if statement. Whenever you see an if statement, you want to look at the entire statement and see if there is a corresponding end to that statement. So I know that this if statement has an end, but this if statement does not. That is a handwritten end. So I need to add the word end to my if statement so that it will run. If I run it without my if statement, my code will just crash. So in line 11, you need to add the word end, or line 12. Note that if you have any loops or if statements, and they do not, the first thing you should always check is to see if they have a corresponding end. And you should always check that if there is a if and then an else, that that whole section has its own end. This is more important when we have nested if statements in a debugging problem. Here we just have 2 separate ones, but in the future, make sure you note that for every if statement, you need to check for an end. Just check for it immediately. Looking at line 9, we see if wave is less than 380 and wave is greater than 750. Now, this is an example of a computational error like I was describing before. Line 7 has a syntax error because this S will cause an error in our code because we're not looking for a string. But in line 9, technically this if statement would run just fine with these conditions. But these conditions always will make the if statement false because no number can be less than 380 and greater than 750. This if statement is trying to check if the wavelength is outside the visible spectrum. So really what this is supposed to be saying is that it wants to check if the number is less than 380 or greater than 750. So in line 9, our corrected line of code is if wave less than 380 or wave greater than 750. Moving down to the next line, we see error, your wavelength is outside the visible spectrum. Now, okay, usually when we have an error function, if you're familiar with it, you should know that the text, the error message here that you write should highlight pink just like in the input statement. We don't see that here, and if we look carefully, we see that there are no apostrophes or quotation marks in our error message. So our error message has an error in it. And so to correct that, we just add our apostrophes to our error message. Note that with an error message, you do not need a semicolon because the error will be thrown regardless. You could add a semicolon, but it is correct either way. Moving down, continuing to move down, we look at line 13. If 380 is less than or equal to wave, less than or equal to 495. This is a syntax error because this is just not how if statements work. So if what we're trying to do is have a wave variable that is greater than 380 but less than 495, we need two conditions for that. You cannot have a logical comparison that is comparing some condition or some variable to two things at the same time. You just can't do that. You have to compare one thing to one thing, be it one vector to one vector or one value to one value. You can only compare two things at a time so that you get yeses or nos. So this statement needs to be modified. We can modify this by just comparing wave to 380 and wave to 495 separately. So in line 13, this if statement should look something like this. So I've added the AND operator so that when I am looking at this if statement right here, I get this part of my condition and I get this part of my condition that I'm looking for. Note that you could rearrange these in your correction. You could say if wave is greater than or equal to 380 instead of if 380 is less than or equal to wave. That's fine. Again, if your correction works, then it is correct. It's as simple as that. Moving down, we see color equals violet blue. Nothing's wrong with that. It's saving it as a character array, which is totally fine. Else if 496 less than or equal to wave, less than or equal to 590. Okay, that's the same kind of error as line 13. So in line 15, it should read else if 496 less than or equal to wave and wave less than or equal to 590. Again, you could rearrange these, that would be fine. Moving down some more, we see an else if here. Now, this line of code is what I was talking about earlier. There are actually two ways to fix this line of code right here. That would both be accepted. You could either remove the if, because an else if needs a condition, and so if you remove the if, we just have if this, else do whatever else. If we don't meet either of these conditions, we do the third thing. Or this could be an else if statement. Since these two first conditions are covering chunks of the wave spectrum. This last chunk is just the rest of the wave spectrum. So you could either write just else, or you could write the actual if statement to cover this spectrum of code. So for line 17, else is fine, or you could write else if 591 greater than or equal to wave and wave less than or equal to 750. Note in all of these, the AND operators are necessary. You can't have an OR operator here because let's say I wanted a number, I wanted to fulfill this condition here. I couldn't, this condition here. I couldn't say 380 less than or equal to wave or wave less than or equal to 495 because let's say I had the number 550. Well, 550 is greater than 380. So this condition will work if this was an OR statement instead. That's why these AND operators are important. Moving down our line of code, we have our end statement that corresponds to if. That's a good thing. And finally, we get to our print statement. The wavelength %0.0f is in the %s color range. Okay, so whenever you're looking at a print statement in a debugging problem, make sure that the variables that are given here that you need to be outputted match whatever operators are in the print statement, whatever formatting options. So here I have a %f, I'm expecting a number. Here I have a %s, I'm expecting a string or a character array. Looking at my variables, okay, wave, that's a number, color, that's text. Okay, good. So that should be fine. But one thing you have to notice, or one thing that you have to be careful about, is that case matters in MATLAB. You cannot have a variable that changes the case of its letters. So wave in line 7 is defined as, in all caps, WAVE. Wave right here is not defined in all caps, it's all lowercase with WAVE. So this variable, if you look through the code, is not defined anywhere else in the code. So this variable is wrong. This variable needs to be corrected to be in all caps. So in line 21, I'm just going to say f print f dot 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 wave all caps color lowercase. And again, an fprintf statement is like an arrow statement. You don't need the semicolon, but you could add it if you want. Either is fine. So again, when you're going through a debugging problem, make sure you read to see how many mistakes are supposed to be in the script. Read the comments at the beginning and read any comments that are inside so you know what it should be doing. And then make sure that you pay attention to things like syntax errors, so adding a term when there shouldn't be one, or missing your apostrophes, or conditionals that don't make any sense. Make sure you watch out for all of these. In addition to syntax errors like these, in addition to errors like these, we have syntax errors here in which the code would crash. We have a computational error here in which it would just give us the wrong, it wouldn't compute correctly. We can also have a computational error with our indexing. So let's say I have a table here, has the cost of a bunch of parts. It has their material cost, transport cost, and manufacturing cost. Let's say I want to manipulate the first column of values. And let's say this is called array. So if this is what I'm manipulating, and I want to, and say in my debugging problem, I am just using the first column, right? Let's say my line of code in that debugging problem calls array 1. This is what I should get. I get array, all rows, first column, okay? Now let's say I want to look at let's say I also want to do some calculations with the second row. And my line of code is well, now this is just backwards. This doesn't make any sense. So this is calculating with first column but this right here, this index is not what we're actually looking for. This is second row semicolon all columns. So second row, that would be this B10 part and all columns, but that's not what we're looking for. We're looking for this. So that would be a computational error. If you ran that value, it wouldn't error in your code, but it wouldn't give you the value that you're looking for. So you'd have to fix this and say in line, oh, let's just say this is line 2. So in line 2, you need your array to instead say something like that, so that you are computing the correct value.